All right, ladies and gents, 5.4 today. This is the end of chapter 5 material that we have to do. Our next chapter we get into, 6.1 and 6.2, is law of sines, law of cosines. You should remember that from algebra 2. You should remember that from geometry. So it's going to be a little bit of a review, which is good. So we're going to have our 5.1 to 5.4 test next Friday, a week from today. After this lesson, we have no more new material that we're going to learn. So you guys have a pretty lengthy, it's not that bad, but it's kind of a long web assign that's going to be due Wednesday morning. You guys are off school Monday, so Tuesday you can work on the web assign in class. You can ask me questions, that sort of thing, like we did yesterday. Then we'll just have a good bit of review on Wednesday, the half day, and Thursday of next week, and then we have our test on Friday. So this is the last bit of material. This is called sum and difference formulas. Guys, what does the word sum mean? Add. And what does difference mean? Subtract. Okay. Now these formulas, there's 6 of them. Do you see? 2 for sine, 2 for cosine, 2 for tangent. You will be given these on your test. You do not have to memorize these. But this is a way of finding the exact value of different angles that are not on the unit circle. You can use angles that are on the circle to add up to or subtract from in order to find these values. So what essentially we're going to do is we're going to be asked a question, and it's going to ask you for the sine, cosine, or tangent of something, so you have to figure out which trig function you're looking at. Then you're going to find 2 angles on the unit circle that either add up or you can subtract to find the number you're finding, and then you pick the formula to use. It's very, very straightforward, very simple. It just takes a little bit of time. So in example 1, there's 2 examples. How are A and B different? One's in degrees, one's in radians. Okay, no big deal. You're finding cosine of something, sine of something. We think in degrees. You guys think better in degrees, so something's in radians, just go ahead and convert it to degrees, and then you can go from there. But on your test, you'll be given your identities, you'll be given the sum and difference formulas, and you'll be given the unit circle. So everything you need will be right there in front of you. So if I look at this first example, letter A says cosine of 75. Now, there's a couple different ways to do these problems. You can find 2 angles on the unit circle that add up or subtract to give you 75. There's different combinations. Gabriel might choose one, Justin chooses another, Gabby chooses another. It doesn't matter. You'll end up with the same answer. It does not matter, just as long as you pick 2 angles that are on the unit circle. So what would you guys pick that would add up or subtract to give you 75? Angles on the unit circle. What plus what would give you 75? 45 and 30? Okay, that's easy. So I'm going to add 2 angles. Fairfoot said 45 and 30. Perfect. We're looking for the cosine. So you go up to your formulas, and you say, okay, cosine. Do you see the 2 cosine formulas? I'm going to use 2 angles that add up to give me 75. Guys, notice, this is why it's really important to pay attention to what you're doing. In the addition formula for cosine, what sign is in the middle of the actual formula? A subtraction. Okay, so just pay attention. You're going to have these. You just got to plug in. Good thing to do is to stay organized. So I'm going to assign. I'm going to say, okay, I'm going to make U is my 30-degree angle, and I'm going to say V is my 45. Does it matter, since we're adding the 2 together, which is 30, which is 45? No. If I was subtracting, then yes, it would matter, but here it doesn't. So now I'm going to go to the unit circle, and I'm going to write down the ordered pair. That is 30 degrees, and that is 45 degrees. 30 degrees, do you guys see, is root 3 over 2 and 1/2? Okay. So I'm going to write right here, 30 degrees is root 3 over 2 and 1/2. This part is not required. You are not required to do this. I just think this will make your life a lot easier. 45, I know, is root 2 over 2 and root 2 over 2. All right, make sure your signs, S-I-G-N-S, are correct. Positive, negative. Now, Remind yourself, guys, I have my ordered pair set up. Which is my cosine value and which is my sine value of an ordered pair? Okay, cosine is your x value. And what is the y? Okay. Again, not required, but very helpful. Very helpful as you're doing this. So now what we're going to do is fill in the formula. The formula for when you take two angles and add them together to find the cosine is the cosine of u. So I'm simply going to write down the cosine of u. What is my u angle? So I'm going to say, you know what? Let's even do it this way. Let's do cosine 30. Let's fill it in a little more. Times the cosine of what? 45, okay. Minus the sine of what? What's my u? Sine 30 times the sine of 45. Again, this step is not necessary, but might be helpful for some of us to actually see. So now when we fill in, ladies and gents, all you're doing is filling in the x and the y values of the ordered pair. What is the cosine of 30? What is the x value of 30 degrees? Root 3 over 2. So square root of 3 over 2. What is the cosine value of 45? Root 2 over 2, okay? Minus, what is the y value of 30 degrees? 1/2, good. And then what is the sine or y value of 45? Root 2 over 2. Now we have simple simplification. What is the square root of 3 times the square root of 2? The square root of 6 over 2 times 2 is 4. Can I simplify that, ladies and gents? No, because 6 is underneath the square root, 4 is not. Okay, so I have minus, what's 1 times the square root of 2? The square root of 2 over, what is 2 times 2? 4. Can I simplify that? No. Can I rewrite this as one fraction? How can I? Because they have the same what? They have the same denominator. So the exact value of the cosine of 75 is the square root of 6 minus the square root of 2 over 4. And there is your answer. What you're doing is the first thing you do is identify the formula that you're going to use, because you're going to say, okay, I'm trying to get this degree measurement. I'm going to find two angles that I either add to get that or subtract to get that. Pick the formula that you're going to use, sine, cosine, tangent. Did you add the two angles? Did you subtract? I personally think it's a really good idea to identify your u and your v and then write the ordered pair. So you're not going back and forth to the unit circle and back, because it's real easy to make a silly mistake at looking at the unit circle. So if you just have everything right in front of you, you just fill it out, and it's really straightforward. Now again, some of you might have chosen different angles. You could have done u was 45 and v was 30. You'd still get the same answer. You will still get the same answer. Let's look at the next one. What does the next one say? What's the question? Sine of pi over 12. Okay, well, first of all, I know I'm going to use the sine formula. Is pi over 12 on the unit circle? No. So let's convert it to degrees so we can know kind of what we're looking at. How do I do that? 180 on top, pi on the bottom. Good. So this crosses out, this crosses out. What goes into 12 and 180? Okay, let's try 6 first. So 6 goes into 12, 2. 6 goes into 180. How much? 30? Okay. Can I simplify more? Okay, so 15 degrees is what we're looking at, right? So sine of 15 degrees is what we're finding. Okay, we see that the sine of 15 is not on the unit circle, correct? Okay, so are there two angles? There's a bunch. There's a bunch of combinations. But what are two angles that I could add or subtract to give me 15 on the unit circle? You want to do 45 and 30? Okay, what's another combination I could do? 60 and 45. What's another combination I could do? Right? There's 150 and 135. There's a bunch. You guys can use any combination on the unit circle. I'm going to stick with either 60 and 45 or 45 and 30. Why? Okay, they're smaller numbers. Not really like the smaller numbers matter because the ordered pairs all the way around are the same. But what do we know about everything in the first quadrant? It's all positive. Your negatives will work out if you use different all the way around. It's just easier for me that I don't mess up signs. So let's do 60 and 45. So I'm going to do 60 and 45. So which formula am I going to use? The sine formula, right? And what am I doing with 60 and 45? Subtracting them. So I'm going to use this one right here. The second formula, right? So I'm going to write it out. I'm going to say sine 60 minus sine 45. I'm just going to write, just so I know which formula I'm using. So help me out, guys, so I fill this in correctly. It's sine u minus cosine, right? So it's sine times cosine v, right? Minus cosine what? U times the sine of v. That's the biggest thing right there, is make sure you write your formula down correctly. So I'm going to do the sine of 60 times the cosine of 45 minus cosine 60 times the sine of 45, correct? Just so in my mind I see that I have everything right. So my u, I'm making 60 degrees. My v, I'm making 45 degrees. And then what are my ordered pairs? What's the ordered pair at 60? 1/2 and, okay, so 1/2 root 3 over 2. And then 45 was root 2 over 2, root 2 over 2. Okay, and again, I'm going to just label real quick. This is my cosine value, and this is my sine value. So I have it right there in front of me. All I have to do is just now, super easy, guys. Sine of 60, that means the y value of 60. What is that? Root 3 over 2 times cosine 45, which is root 2 over 2, minus, what's the cosine of 60? 1/2 times root 2 over 2. Now we simplify. What is the square root of 3 times the square root of 2? The square root of 6 over what? 4. Minus, what is 1 times the square root of 2? Square root of 2 over what? Over 4, which gives me root 6 minus root 2 over 4. A lot of times you're going to get very similar looking answers. Guys, can you simplify the square root of 6 minus the square root of 2? No. Those are two different numbers. It's not that you can combine that to the square root of 4 and then that's 2. That does not work that way. Questions? All right, so we can rewrite this over one denominator as what? Square root of 6 minus the square root of 2 over 4. All right, we good? Yep. All right, the next kind of example is the exact same thing. It's just giving you a little bit of different information that you guys have to kind of decipher. Again, you're going to be given the unit circle. You're going to be given your identities. You're going to be given your formulas, all that stuff. This question says, find the exact value of sine u plus v given this information. Okay, given this information. This is very helpful information. We already know this. This is giving us everything we need to know. You guys just have to extract it. First of all, they're telling us which formula to use and what you're doing with u and v, correct? So we have to understand that we're talking about two different triangles here, two different angles. We're talking about u and v. So we're going to think about this separately. They told me about u. I know these little tidbits of information. The sine is 4 over 5. What is sine? Y over what? Okay. This isn't on the unit circle, though. So remember, when we didn't have stuff on the unit circle, we had to use our X, Y, and what letter? R. Okay. So what we're going to do is we're going to find X, Y, and R for the U triangle. We're going to find X, Y, and R for the V triangle. And then we can figure everything that we need to know out. All right, so I know that with my sine of U, I have 4 over 5. So this is Y over what? Y over R. So it's 4 over 5. Now I need to find X. How would I find that? Okay. There's one little piece of information, though, that is super important, and that is this. That says that this triangle that we're talking about, this angle that we're talking about, is between 0 and pi over 2. So think about where that is. Here is 0, and here is pi over 2. Sarah, what did you just say? It's in what quadrant? Okay, why is, excuse me, why is that very important information? I know where to put negatives. Good, Jules. I know if it's in the first quadrant, what are X, Y, and R? All positive. So I don't really have to worry that much. I'm going to say, okay, X squared plus 4 squared equals 5 squared. Agreed? Okay. So I have X squared plus 16 equals 25. Minus 16 from both sides. X squared is what? 9. Hi. Take the square root, so X equals what? 3. Okay, so I know that the X and the Y and the R for my U triangle are 3, 4, 5. Now I'm going to go one step further just to make this easier on myself. Just to make this easier on myself, I'm going to write down what the sine, the cosine, and the tangent are. So I don't even have to think when I go to put it in my formula. It's just right in there for me. So the sine of U. What is sine again? What over what? Y over R. So my sine is 4 over 5. What's the cosine? X over R. So it's what? 3 over 5. And what's the tangent? Y over X. 4 over 3, right? Okay. So this is my U triangle. I have not found out anything yet other than those values. Now we're going to do the exact same thing over here for V, and this is going to help us out a lot. I'm going to find out my X, I'm going to find out my Y, and I'm going to find out my R. So they gave me that cosine is negative 12 over 13. Well, what is cosine? What over what? It's X over R. So I know that X is 12 and that R is 13. What do I know about 12 or 13? R can't be negative, so I know that X is negative. Okay, good, very good. So this is really important information too. They're telling me that this angle is in what quadrant? Where is pi over 2 and pi? What quadrant is this triangle in? It's in the second. So what do we know about the signs of X and Y in the second quadrant? Y is positive, X is negative. Okay, we're good. So now all we have to do is what? The Pythagorean Theorem. We're going to find Y. So I have negative 12 squared plus Y squared equals 13, right? Okay. Oh, yeah, my bad. Thank you. So 144 plus Y squared equals 169 minus 144. So Y squared is? Y squared is 25. So my Y value is 5, okay? So now I'm going to go ahead and help myself out, and I'm going to write down the sine, cosine, and tangent for V. So I have the sine of V, the cosine of V, and the tangent of V. What is sine? What over what? Y over R, so it's 5 over 13. Cosine is negative 12 over 13, right? And tangent is Y over X, so 5 over negative 12. Now, have we even begun to solve this problem? No. We just took all of the information that we've done in the last, 2 chapters and found trig functions of 2 angles in different quadrants. Not in this problem, but sometimes you might. because they might ask you for the tangent or something. So I just always get in the habit of finding all three. So now let's go back and ask, okay, what is this question that they're asking me? They're asking me to find the sine of u plus v. So the first thing I need you guys to do is look at your sine formula for u plus v and tell me what to write down.
4/5.
No, just the words, I don't even want to fill in yet. Okay, sine u times what? Cosine v. Now, some people ask me, can I use different letters? Because sometimes my u and v's look the same. Sure. Use 2 different letters. Doesn't matter. Use x and y, whatever. So, I'm sorry, I digress. Sine u times cosine v, then what? Plus cosine u times the sine of v. Now, this is why I think this step here and this step here is so important. All you have to, if you guys just take 2 seconds to just write down for each separate triangle the sine, cosine, tangent real quick, then you don't have to go back and think. You're honestly just looking and filling in. Do you see what I mean? At this point, if you just had your x, y, and r, you'd have to then go back and be like, okay, sine is what over what, and then put it in. Again, you can do that if you want. I just like to have it right there in front of me so I don't even have to really think. Sine u is what? 4/5. Perfect. Cosine v. -12/13. Good. Plus cosine u 3/5 times the sine of v 5/13. Now something will happen every single time if you do this correct. What do you notice about the denominators of the first 2 and the denominators of the second 2? They're always going to be the same. If you get it to where it's not, then that should be a little like, whoops, I made a mistake. And that's okay. You just go back and fix it. But now we just simplify, guys. What is 4 times -12? -48, good. Over, what's 13 times 5? 65? 13 times 5? Yeah. Plus, what is 3 times 5? 15 over 65. Good. And now what can we do? You can subtract or add, however you want to say it. But what's a net combine? What's a -48 and a +15? Negative what? -33/65. And then the last step is to see if you can do what? See if you can simplify, which we can't. So there we go. And that, ladies and gentlemen, is your sum and difference formulas. Okay? You're going to see it. There's one other way that you're going to see it, but I'm just going to show you on the review. And all it is working backwards. It's super simple. But on your test, you'll either be given, here's the angle, find, the tangent of it using the unit circle. Or here's some information about triangle U and triangle V. Figure out all the stuff and then do something like this. Sound good?